I'm Matt. I'm a creative coder and generative artist, and today I just wanted to talk about generative art and my passion for it. Hopefully share a little bit of that with you guys, talk a bit about my tools, my workflow, and also where I find inspiration and how that's sort of evolved my, my art and my path. And so when I talk about generative art, I'm really talking about making machines that make art. Making a system or process that is able to produce something in some way without control from the artist. So creating an autonomous system. This doesn't necessarily need to be code related. Sometimes it could be like a biological process or working with like a coin flip or a dice roll. But usually for me, it's writing code and writing code that produces images and sometimes other artwork as well. I've been interested in it for a while, since around 2014, and that's when I first created this web demo with JavaScript. And I called it Generative Impressionism. I tried to create a sort of painting out of a photograph. This is when I was just learning this kind of stuff. And I began to realize that using code and writing code, I could actually produce images that in some way look a little bit artistic. Rather than just making code for functional purposes, I can also use code for artistic purposes. And that was an interesting revelation, but I sort of parked it on the side, and then a few years working at an agency. And it wasn't until 2017, in May, where I got a pen plotter, an AxiDraw pen plotter. And that's where my work began to shift a little bit. And so for those who don't know, this is what a pen plotter looks like. And it's a mechanical robot where you attach a pen on the end of it, just any normal pen. And you can program the robot to draw out any commands you want. And it can be very detailed and very intricate. And you also get this result that is a print that is clearly done by a robot because the lines are so intricate and so detailed and so accurate. But it has these kind of imperfections and these moments of errors sometimes when it catches an edge or the ink dries up a little bit. And so it has this really interesting original result. And this is where I started to realize that maybe I'm not just interested in doing art on the web and art in digital forms, but maybe I can also use code to produce art that is in physical form as well. And so I started to code these things in JavaScript, by the way. This is the language that I was familiar with, and this is the language that I like to use. And so I started to code it all in JavaScript, and I realized that there wasn't a lot of tools for pen plotter with AxiDraw and with JavaScript. I was sort of trying to enter this landscape and figure out how do I improve my workflow, and how do I actually go about doing that? So I built a tool called PenPlot. It's on GitHub. It's open source. It's very experimental. It doesn't really work all the time. But it just allows me to iterate in the browser, draw out these like simple geometric shapes in the browser, and when I'm happy with the result, I can very quickly export it as a PNG or as an SVG file and send that file to the printer. And over the course of several months, from around May of 2017 until around January 2018, I created a lot of outputs with this tool. And these are all the outputs that are PNG outputs from the actual tool itself that, as I was coding these different generative algorithms or procedural outputs. And as you can see, the actual way I'm using the tool is beginning to evolve a little bit. And so this is 960 different images. And as I go through, I'm beginning to introduce sometimes color or thicker lines that you can't really translate into a pen plotter, sometimes fills and different ways of writing code to produce images. And I'm beginning to realize that this tool is actually just a really nice workflow for creating images with code. And it's not necessarily constrained to a pen plotter, and it's not necessarily constrained to thin lines. And so this is really me iterating and evolving this tool and realizing that this tool is potentially becoming sort of part of my workflow and part of the way that I create these images and create this artwork. And so yeah, I'm just going to run through the rest of these. There's quite a few more, but not that many. And that's where I started to use a different tool. And so the outputs are different file format. But that was basically 950 images from that tool. And through this whole process, I felt like I was beginning to find a bit of a style, and it was beginning to develop a little bit. And it's really because of this tool I was realizing it was helping develop my style and develop a style. And this is sort of something I realized, and it's kind of a takeaway, it's a bit of a reminder, is that our tools really shape the output of our work. So for example, this image was created in Blender. I created that in Blender, and it's got a different aesthetic, a different style than anything that I was doing with my pen plot tool. And so this is just something that I began to realize and began to really realize is important, is that in order to break out of a certain style or in order to develop my style in a more refined way, I actually had to hack my tools and evolve my tools and use them in different ways and use them in ways that maybe I wasn't using them before. And so that's what kind of led me to this other print series called Crystal Towers. And it's 10 different cities that are, it's sort of a data art series. It's 10 different cities, and the skyscraper heights of each city mapped into these procedural generative 3D structures. And the way I actually created this series is using the pen plot tool, using the same tools that I was using for my pen plotter and using for 2D. And I realized I could just sort of add a third dimension and export them as 3D files, and then bring those 3D files into Blender. And so this is where I started to hack my tools and evolve my tools, and it started to help me shift into new styles and new outputs. And also I began to find this new interest in actually producing prints, not just producing pen plotter prints, but potentially ink prints with like a fine art print studio. And so these are a couple of the outputs. And yeah, so this was rendered in Blender from a JavaScript OBJ file. And all the while, as I'm doing this, I'm not doing it in a vacuum. I'm sort of following and communicating with other artists on Twitter. There's Anders Hoff, who is very well known for his pen plotter artwork. And he is sort of the one that got me into using an AxiDraw. It's because I saw his work. He also goes by Inconvergent. And he works with differential growth and really interesting generative algorithms, and he quite often pen plots them on a very large scale, and they look really pretty. And then also there's Joni Lemercier, who's here somewhere. So his work is really inspiring as well. He's not always pen plotting, but when he does, it's quite often like this really beautiful landscape artwork. And he even went as far as to bring a pen plotter in his backpack through the Nevada desert and actually plot on site these really interesting landscape prints actually in the desert. So I thought that was pretty cool. And then also, as I'm sort of following this community and looking for more inspiration, I find the work of Manolo Gamboa. And his work is using processing, so it's a different tool, different style. And it reminds me of the importance of going back to color and not limiting myself just to lines and just to pen plotter artwork. His work is really fresh, really colorful. Definitely check it out. It's worth a look. And as I'm sort of discovering more art and more artists and more inspiration from these artists, I'm also looking for art in the past. And I stumble upon Vera Mulder. And I realized that the pen plotter work that I'm doing today is not very new. And it's been done since the 60s and 70s by artists like Vera Mulder, as well as other artists. This is a print that she did with a pen plotter in 1968. And she used code, but she wasn't able to see the code with a tool like the AxiDraw and my pen plot tool in the browser with JavaScript. It obviously wasn't as easy back then, but she was still able to produce these very interesting generative outputs using probably many of the same techniques that we use today in generative code with pen plotter. So it was very humbling to see that and also very inspiring. And it was really amazing to actually see it in person. Her work has been exhibited in a lot of different museums. In Paris here, there was at Grand Palais, there was an exhibition, and a couple of her works were there. And so it was really beautiful to see that in person and realize that sometimes these pen plotter artworks can actually be printed and exhibited. And so as I'm going through museums and going through artists and trying to find more inspiration through these artists, I stumble upon the work of James Turrell. And I realized that his work is really inspiring to me, and he's an artist who was very popular in the 70s and beyond. And his work is really around light and space. That's kind of the movement that he was part of. And he produced these really, really iconic large architectural pieces, quite often with light. And that gave me a lot of inspiration, and it sort of led me into wanting to do these kind of pieces myself. And so this was a sculpture, like an interactive light sculpture, we took some of the same inspiration of creating a piece in nature and using light, but then making it interactive, bringing some of the concepts that we had learned with code. And it was me and 2 other friends in Toronto, where I was born. And we created this, it's sort of like a sculpture that is this beacon of light. It's a cold blue light in the middle of the forest, and Canada is really cold in the winter. So this is kind of the idea, is that it's like a warming hut, like throwback to the past in historical, like Canadian hiking type thing. And this cold blue light, when you approach the structure, the cold blue light, it turns like a warm red hue, and it's actually in response to your body heat. So you being there in this cold surrounding, it notices your heat and notices your body heat, and it brings that to the light, and it changes, and it interacts with you in real time. So I'll just show you a little video, just like a quick promo video.
We wanted to create an experience about the cold and the warmth.
We want people to go up to it and interact with it and have this sort of surprising moment when it changes in response to them being in front of it.
It's super emotional, kind of, especially during the night. When you have this light in the middle of nowhere, you have a kind of emotional reaction to it, and you want to get closer and you want to interact.
So yeah, you can see it's a very simple concept. It's not really that deep in terms of meaning or concept. We just wanted to create a sculpture that's in the middle of the forest, in the middle of nowhere, and it was part of Ontario Place's Winter Light exhibition. So it was stayed up in Toronto in this public park for several months during the winter and during the cold season. And it was a really important project for us, for me and my 2 friends, Stephen Manger, who's a designer in Toronto, and Jean-Michel Gariepi, who's an engineer in Toronto. And it was just really important for us because it was kind of our baby, our little project that we were able to create ourselves without any outside influence. We created it from the ground up, from the mock-up and proposal stage. This is a design that Stephen did before we really knew anything about the project, and we're happy that it resulted just like our design and our idea. And I actually had to learn quite a bit about Raspberry Pi and LEDs, and how to wire these things together, and electronics, and I had to solder stuff for my first time, and we like totally did everything wrong the first time we did it. Had to do it all over again, but it ended up working surprisingly, and the Raspberry Pi code still works today. It's just been like running ever since we put it up, and somehow it hasn't died yet, so that's great. And actually, it's using some of the same like generative shader code that I was learning in WebGL and with GLSL. But it's doing it in C++ in the CPU, and it runs quite quickly. And it's really just an ambient loop of color, but when you put this frosted pane of glass in front of these LEDs, it produces this really soft ambient light. And we actually also, I don't know if I mentioned, but we have a thermal camera in the setup that was attached to the top of the pyramid structure, and the thermal camera connects with the Raspberry Pi, detects your body heat, and then reacts, the light reacts and the image reacts. And we actually went through like designing this entirely. We really wanted to like make sure that everything was designed and spec'd out exactly. So the engineer friend of mine, Jean-Michel, he was working on the CAD drawings, and it was really interesting to see that process and see how you can model something in 3D and then basically send that to a 3D printer or a place that would assemble it. And actually, in the case of the thermal camera, we had a mount where it was just something we designed in a 3D software, like a CAD software, and we exported it and then printed it in 3D, and that was what encased the thermal camera. And then there it is in the shop. This is working with our fabricator, Christine DeWanker, in Toronto, and it's almost ready, and then we just had to move it and put it on site. And basically, this whole process, we were in parkas because it was freezing, and it's like right by the water. It's very cold. And then here it is in the final sort of thing. And this image on the left actually came from social media. We didn't take that image. And that's one of the nice things is if we started to see this image popping up, these people taking pictures of it on their own, and some people really spending a lot of time framing it and trying to find a nice angle. And then we also got like stories, Instagram stories and Snapchat stories from random people that were playing with it. Sometimes a kid would run in front of it and like run around it. And sometimes people would take selfies with their dog or whatever, and that was really cool to see. But really, this whole project was a reminder that it's really important for me to collaborate across disciplines and to work with other fields. For example, my engineer friend, Jean-Michel, when we would brainstorm together, we'd have this kind of collaboration that was different than if I was just brainstorming with another developer or another coder. And so that was really an important reminder. And all of this is sort of leading me to realize that I'm really trying to find more inspiration. This project and all the stuff before it, I'm trying to find more artists, and I'm trying to find more work that inspires me because it ends up uplifting and helping my own work and just helping me along. And so I'm going to museums, I'm going to exhibitions, and just trying to find what's out there and trying to search around. And this is where I learn about Sol Lewitt's work. And Sol Lewitt is an artist that was really popular for his wall murals in the 60s, 70s, and beyond that. And he did these really huge, expansive wall murals, these wall drawings, and he did hundreds of them. And they're exhibited in all sorts of different museums, galleries all over the world. And here's another one. And when you look at his wall murals, you might start to think they look almost a bit computational. They almost look a bit like something you'd see maybe in creative coding kind of communities. But actually, he's not really using computers to do these things. He's not even really painting them himself. This is one of the interesting things about his work, is that he's not going onto the wall and drawing it and creating it himself. Instead, what he's doing is he is creating instructions, and he's creating very simple instructions. The instructions for this actual wall mural are so simple that they can be described in a single sentence. And this is the sentence that he would give to the builders, to the fabricators, to the people that are actually creating that mural. And so rectangles formed by 3-inch wide India ink bands meeting at right angles. And he'd provide an instruction like this, and then he'd provide sometimes a sketch or a draft. And from that, the actual people would be the ones producing, the builders or the draftsmen or whatever, they'd be the ones producing the mural. And so there's a lot of parallels with the work that we're creating with generative art, with creative coding, where the humans in this case are the machines. They're the generative system that we're working with. And so he hands those instructions off to a set of humans that build it. Whereas for me and for many other generative artists and creative coders, we're writing instructions and writing rules and parameters, and we're producing that with a machine instead of with humans. And so I just thought there was a lot of parallels, and his work really resonated with me, and it's really interesting. And also he has a lot of writing on art, and there's some gems, and it really is very similar to the way that many generative artists work, and sort of with this element of improvisation and element of sort of dancing and playing with the machine to find new outputs. Here he says, the art process is carried out blindly. There are many side effects that the artist cannot imagine. These may be used as ideas for new works. And so that's something that I also find myself doing a lot, is just iterating and experimenting, and from that it produces many new ideas, sometimes that I was never expecting in the first place. And that's one of the beauties of generative art, is you don't always know the end result, and sometimes along the way you find multiple end results. And so learning about Sol Lewitt and learning about his work, it's really showing me how simple instructions can create complex results, and how there's this elegance where you have a simple set of instructions and a complex result from it. And so here's a project where I tried to do a bit of this. It's a generative algorithm that produces these images that look a little bit fractured like this. It produces very many different iterations and many different outputs depending on the parameters you feed it. And I tried to make the instructions simple enough to explain to most people. And so the instructions are like this. You use a large set of random 2D points. You select a cluster of points, and then you outline it. And then you remove those points from the data set. And you repeat from step 2 on the remaining points. And so it sounds maybe not too complicated, but I can actually show you how it works. So if you start with a random set of points like this, and then you select a single cluster of those points, you outline them, and then you fill in that shape maybe with a color or maybe just with white. And then you do that, those steps again and again and again. On the remaining points, you just create new clusters. And you end up with a sort of fractured look. And then if you were to just simply start again with many more points in the start of the algorithm, you end up with this more dense and more detailed output. So I thought that was kind of interesting that these few simple steps that could be explained to many people could produce this graphic that has so many different variations and so many different outputs and does look quite complex. And here it is rendering out just so you can see how it's working. And in this actual GIF, it's the algorithm is being done over and over again recursively on smaller and smaller polygons. And that's what's creating even more complexity. But still, it's quite a simple set of rules that's creating this complex image. So I thought that was kind of interesting. And then another thing about this algorithm and many of these generative algorithms is that they can be applied in 3 dimensions. And so this is the same algorithm and the same tools and techniques I was using to export my OBJ files before. Here I'm exporting them as a 3D model and then rendering them in Blender. But you can imagine the same process could be done to create parametric and generative models that are then 3D printed or perhaps assembled in some way in the real world. And so as I'm looking through Lewitt and as I'm trying to find more inspiration in artists and museums, I'm also finding a lot of inspiration through design and minimalism and these ideas of less is more and those kind of concepts. And I'm starting to realize that there is a lot of inspiration that I can find in design and branding and those kind of fields. And so here's one example of what I'm trying to get at. This poster on the far left, it's using these 3-dimensional sort of 4 planes that are maybe using a faded material of some kind. And when I was really into graphics programming and when I was learning a lot about WebGL and shaders, I might have not even tried to do something so primitive or so simple because I might have thought there's no use in doing something so simple as a mesh basic material in 3JS or something like that. But now I'm trying to take a different approach. And I'm trying to say that there's no such thing as too simple, and it's very powerful to have a simple shape or a simple primitive geometry and to work within those constraints. And you can actually end up producing a lot of different output. For example, here's these posters, but then also the same system can be used to just create outlines or create a mask or something like that. And I think there's just something that is valuable there as to, for me at least, is to not be afraid to do simple outputs. Here's another example of what I'm trying to get at, is this branding for Primary, a company by DIA Studio. And by the way, DIA Studio does amazing typographic work and generative stuff as well. And this is a generative system that creates this sort of rainbowy circle. And as a graphics programmer, I might have looked at that initially and thought, oh, this is just a shader that's like using a fragment shader. And so I need to do something more complex. I need to use ray marching, or I need to use like sign distance fields, or I need to do something crazy complicated. But now I'm trying to say, OK, there's no such thing as too simple. And there's actually like a power in that simplicity. And it can be applied in many different ways, in many different outputs. It doesn't need to just be an image or a GIF. It can also be rendered and brought into print. So there's something magical, I think, about that minimalism. This is where I've tried to actually apply some of these ideas of minimalism. And so this is a game that I created recently for mobile and desktop. It's a generative art game. And the whole thing is procedural. The audio is procedural, and the graphics are all procedural. It's all JavaScript. And this was really my attempt at working within a lot of constraints. And so the whole game is in 13 kilobytes. It's part of a game competition for 13 kilobyte games. So that was one obvious constraint, is that I was very limited in terms of what I could produce. But then also all of the graphics is just lines, just circles, and just trying to keep it simple. And then the game itself is sort of inspired by haiku poetry and the idea of trying to express a feeling and an emotion within a single breath in a very short few words. So yeah, this was a lot of fun to build as well. And then here's a recent print series that I've done. This was me trying to challenge myself when I'm working with WebGL and 3JS. I'm quite often tempted to go straight for a very fancy shader with like reflections and environment mapping and crazy shadow mapping or something like that. But I need to also remind myself that there's a lot of value in just like simple primitive shapes, working with very minimal colors, maybe 2 or 3 colors, and really forcing myself into that constraint. This is just like a daily sketch series. I've been trying to do daily sketches this month, and I haven't been doing every day, but every like few days it's going. And then in July, I moved to London, so that's been a big shift in my life as well. Yeah, it's great so far. I'm loving it. And I'm spending a lot more time trying to build my art and build my tools, and also continue hacking my tools, going back to what I was saying earlier around hacking my tools and how I felt it was really bringing my, my work to a different level and to a different place. And so here's this tool that I've been building recently called Canvas Sketch. Not very original with GitHub names, but whatever. It's a tool that allows me to, just like PenPlot, it allows me to iterate and design generative graphics using code, but in the browser. And so I can visualize what I'm creating in the browser, and then I can export them as images like this. And it just allows me to sort of sketch with code. This is what I'm trying to get to eventually, is just like an illustrator might sketch every few days or every couple days. I want to get to the same state with my code where I can just sketch new artworks, but using code. So these are some of the daily sketches that I've been creating this month. But the tool also allows me to export in high resolution. So using like a 300 pixels per inch type image, and then actually sending that to a print studio, getting back a high quality fine art print from my code. And there's something really magical in actually like holding something you've coded in your hands. So yeah, this tool, like this was a main part of this tool, is being able to export these high resolution outputs. And then I've also realized that the tool can be used for just animation in general, and so I'm using it to create video. And so this is using 3JS and WebGL to create this sort of motion graphics, loops and stuff like that. It can be used to create GIFs, just like seamless loops. And you can imagine this could be maybe shared on social media channels, or also maybe projected using projection mapping or something interesting like that. And then, yeah, so another part of the tool that's really important is just scaffolding. So when I'm sketching, when I'm opening my notebook, I guess you could say, I just want it to be really quick process of I immediately type something and immediately I'm already started. I don't have to think about the tool. I don't have to think about setting any package JSON files up. That handles it for me. So that's quite handy. And then another really important part of the tool is the units. And so typically, when working with code and when working with processing or something like that, you might be working with pixels. But when you start an artwork and you're able to define all of your shapes and all of your graphics using centimeters or using inches, it just gets you thinking in a different way, and it gets you thinking right away from the start that I'm producing this artwork for a physical medium, and I'm producing it to be seen in the real world rather than I'm producing this to be seen on a screen. And so that's just a nice feature of the tool that has been really important. And then this is another feature that allows me to iterate very quickly. It basically, every time I save my code, the tool reloads, and I can see the new result immediately. So that's pretty important as well. And this kind of goes back to like that Lewitt quote, like just improvisation and finding new directions. The faster the reload cycle I find, the more directions I can take my work, I think. And then exporting. So this is something I've been hacking all this time on PenPlot and things like that, sometimes exporting 3D models. And now I'm really making this like a core feature of the tool. So you can export 3D models, you can export JSON, but you can also export any file you want. So if you want to create a laser cut, or if you want to create something that is sent to a CNC machine and actually mill out maybe a 3D object or assemble something that's made with code, you can export those files. In this example, this is a different way of taking it, is to create a print series, maybe with risograph or with silkscreen printing. The image on the far left is like a composite. It's like a preview of what you'll get when you actually combine the 3 different ink colors. And these 3 images here are the layer masks. And so each of these images would be sent to a print studio that might work with silkscreen, or you can print them yourself. And each of those layer masks would correspond to a different ink color. So when I was doing these kind of projects, I realized it's really powerful just to let the tool be able to export anything and any number of images. So a single code sketch can produce multiple different images or multiple different files. And then another really important part of the tool is cataloging and just making my art reproducible and making the work that I export from the tool something that I can come back to. And so when I export a file from the tool, I can export it with a certain keystroke, and it will automatically git commit all of my code that I've written for that image or for that output. And then it'll use the git commit hash in the file name of the exported file. And so what that means is many years later, I can come back to this file, and I can look at the git commit, and I can go back to the code just as it was when I exported it. And so quite often what happens is somebody might say, oh, I want a certain thing that you've done last year or something, but I want it at a different resolution or a different size. So I can go back, I can edit the code, tweak it, remix it, and re-export it maybe at a different print size or something like that. And so that's really important for just cataloging and making sure all of my work is reproducible. And so lastly, I'll just end on like a breakdown of how to create a sort of generative print like this, just to get a little bit more technical, but not too much more technical. And this series, again, there's not like a lot of depth or meaning. This is just a daily sketch series. I like doing these kind of things where it's just abstract images with code. And this one is just based on the prompt reflect. So it's very minimal, very simple. But how actually I go around creating it. So the first step is to get into mood, get into style and the aesthetic that I want to attain. I use something like Pinterest or Behance, or really just finding inspiration in any of the ways that I've been talking about: Twitter, going to museums, going to galleries, etc. But Pinterest is actually particularly good, I find, even though it's a bit controversial by some people. But it's a good way to catalog different styles and different aesthetics that you might want to try and create one day with your own work. And so this is like a gradient board that I have where I'm like, here's a bunch of different gradient stuff, and just try and soak it up. I don't spend too long, maybe 10 or 15 minutes, like looking through this stuff. I find if I spend too long, I just like lose my energy. And then once I've got that sort of idea in my head visually, I try to think, what is the emotion or what is the feeling? And so I often work with like little seed of an idea in a single word or a sentence or a phrase. In this case, I created 30 different prompts for November, for the Codevember sort of challenge, just so that every day I'd be able to wake up and have a new prompt to start with without having to really think about it that much. Yeah, and actually creating prompts and creating words that evoke feeling is a nice challenge on its own. It's a challenge away from the screen, and it's a challenge away from the code, and it just allows you to think about words. And it's those kind of things, I think, they just boost creativity in many ways. So. And then I actually go around sketching. So before I code something, I quite often try to sketch it out a little bit. Here's kind of how I work. It's a lot of little square thumbnails. It allows me to not have to worry too much about the quality of the sketch. I can just really quickly sketch out a thumbnail. These are a bunch of different prompts, but the same thing would be done for a single prompt like reflect. I just try to sketch out many, many different iterations. And sometimes as I'm sketching, I might also be planning a little bit about the code or about how the artwork is going to be created. Yeah, that's how I do that. And then actually I have to create the image. And so to create an image like this, I'm using a Fragment Shader. I'm not always using Fragment Shaders. That's one of the tools that I can use with my Canvas sketch tool is shaders, and some other tools might be more around pen plotting, that kind of stuff. But this one's a Fragment Shader. And the way the Fragment Shader works is it's using GLSL, and it's using a lot of math on like per pixel basis. And basically, you start with 3 random points anywhere on the screen. Those 3 points, they end up making 2 different line segments. This is the first line segment. And in the shader, you get the distance from the current pixel, wherever that might be in the page, to the line segment, the first line segment, which is A to B. And then you do the same thing for another value here, for the current pixel to the second line segment. And then instead of using a linear distance, or sorry, yeah. So here instead of just using a small distance, I'm scaling that so that it's like scaled over the page, just sort of spreads out a little bit more. And then here, instead of using a linear distance, I'm using a random Gaussian function. And that just produces this sort of chaos and noise that I was really wanting in this image. And then maybe I'll just cut one side of it, just so that it's a bit of a better balance. But maybe instead of cutting one side entirely, I'll let some of the light through a little bit using a Gaussian function again. And then I'll introduce like a color maybe, or something like that. And then if I just repeat all those steps for the second line segment, I end up with this green color. So I've got red and green, and when you add those two values together, the output of the image already starts to look a little bit like that print. So here's the result of that. And then one other step would be to, instead of each time we sample from the same line, we sample from a different set of points each time. We just move the points around a little bit in each iteration of the shader. And that just creates this nice feather. So that's the difference there. It's just a feathered edge, and it just makes it look a bit softer. And then instead of sampling one pixel, or one sample per pixel, I'll sample multiple samples per pixel, and then average those together. It's a little bit like stochastic rendering, which you see in like path tracing if you're using Blender or Cinema 4D Octane Render or something. It's kind of a similar concept. It's just getting many samples and averaging them together. That will smooth out the result and make it look a little bit less grainy. It's quite subtle and hard to see on this projector, but it's a bit less grainy. And then the last step maybe would be to super sample, so to export at a really large size, scale it down, and that just smooths it out a little bit more. And then finally, I go into Photoshop, maybe apply some color grading. It's quite subtle, but especially when you go for print or for a screen, it becomes really important. Maybe adding a final grain, those kind of things. And then the thing isn't just exporting one image. It's part of the generative art process is really exporting hundreds and hundreds and hundreds and curating and finding the best outputs from those. And so generally, I'll export 50 to 100, and I'll whittle that down to maybe 4 to 8. And then those are the ones that I print. Those are the ones that I share. And with those 50 to 100 exports, I can squash that all together into a movie. I find this is really nice for audiences that aren't so familiar with generative art. They can see that you're not just creating one image, but you're actually creating a system or a machine that creates images. And so it's powerful to see the process or the series of different images you've created with the tool or with the code. And then I export for different social media channels. This is actually a really big part of my work is just like sizing everything for Instagram and Behance and Twitter. It takes a long time. And so definitely like don't skip out on that. It's each platform has its own constraints and its own, what works best for that. And then exporting for print, just making sure that the print studio gets the file as they want it, what the format is, whether there's margins or anything like that. And then actually receiving the print. This is towards the end of the process. This is where you might sign it, date it, etc. This is a different print series I did. Same process, same tools. And then the next steps for me would be to actually sell and distribute. But I can't really talk about that yet because I don't have tons of experience with it. I don't have this online shop working yet. But hopefully within this month, I will actually have an online shop where I can just sell and distribute this work so that anyone that wants to buy it can buy it. So keep an eye out for that, but it's not ready yet. And that's pretty much it. Thanks a lot. Yeah.